All right. Hello, everyone. My name is Robert Masson. I'm an agricultural extension agent from Yuma County, Arizona. I'm part of the University of Arizona system from the land grant college to help the growers of Arizona with their cropping needs. Today, I'm going to talk to you about regenerative agriculture in the desert Southwest, specifically focusing on a little bit of IPM, but mostly irrigation, salinity, and soil health, and how all that ties together to help you grow crops sustainably and with regenerative agriculture in mind. So Arizona, don't really think of it as an agricultural, worth of anything, really. It's just a bunch of sand and rocks, and for the most part, that's true. But we do have a lot of fertile river floodplain areas. And so the big river that we have is the Colorado River, and that flows right downtown through downtown Yuma. It's often referred to as the Nile of Americas because of all that alluvial deposits being dumped from the seasonal flooding and receding of the water here. And with that combined with our great climate, arid climate, we really are like the Nile of America. We can grow lots of crops in this particular region, part of Arizona, and we supply a lot of the nation's vegetables. So Yuma, we're right here in the desert. We're right here at the intersection of California, Arizona, and Mexico. We are right on the border. We're the last stop on the Colorado River before Mexico. So we've had an ancient water right on the river for a very long time, and we've developed a lot of rich agriculture here. We've had 15 dams built on the Colorado River since basically we settled the West. And because of that, we no longer have that natural flooding and receding that restores the natural resilience of the land. And so now it's our responsibility to do that. We manage our water here in the area through our canal systems that are run by water districts that are non-government organizations. They're privately run companies, mostly run by board of directors that are farmers. And we typically use furrow and basin flood irrigation systems, which I will be talking about more. So over the years, the river that cut the Grand Canyon deposited downstream in Yuma, and we have developed our agricultural systems to take advantage of all that. Some statistics from Yuma: we only have about 200,000 acres here. Nearly all of it is double cropped. And in this one county, we supply 30% of the total state agricultural sales. And that means a lot because we don't really produce any animal livestock here. And that's the big moneymaker. On the east part of the state, they do, but not here in Yuma. This number is very underrated. We produce lots of revenue, greater than 1.43 billion, likely 3.3 billion, but it seems like these numbers just keep going up after time. We're ranked number 3 in the country for vegetable and melon sales. We produce 90% of domestic leafy greens produced in the winter. If you buy a salad anywhere in the United States between the months of November and April, there's a 90% chance it came from this county. We also grow 25% of domestic cantaloupe production in Arizona, most of it being in Yuma County. As an extension agent, I'm really focused on addressing the needs of our public, and I follow this model. First, I go out and find out what's needed through needs assessment surveys and talking to stakeholders. Then I do research, pouring through the data of what's already there, or conducting field research trials myself. I've conducted over 100 field research trials in the 5.5 years that I've lived here. Double cropping lets us get in there twice a year at least, if not 3 times a year if we want to do fall melons. Then we take that information and we put it into education, both in-person, online, that type of stuff. I'll talk more about that later. And lastly, our end goal is on-farm change. And if we skip any of these steps, forget about on-farm change. If we do a lot of research that the farmer doesn't care about through needs assessment, it's going to go nowhere. If we don't educate about what we find, it's going to go nowhere. So we really have to follow this model to get that positive on-farm change in place. My personal program is focused in 3 areas: crop production, where we focus on maximizing the crop growth, developing our skilled labor. We've had a lot of people talking about succession. Well, we're here to help with that. I've employed over 28 interns, trying to train them up in these field research area, get some dirt under their fingernails, Gen Z, all that. They want to work, they just don't have the opportunity. They don't have the uncle maybe that owns a farm, so they just don't have opportunity. And so they get that here with us if they want it. And then we're doing a lot with automated farming equipment, which like automated thinning, weeding, laser weeding, that kind of stuff. There's a lot of money in vegetables, so a lot of that technology comes here. Then we do crop protection. This is mostly integrated pest management. I typically support our extension specialists because this is where the majority of extension is focused. With regards to regenerative agriculture, there's a lot of movement in the cotton and alfalfa world about identifying predator insects that will maybe feast upon the detrimental insects that are in the field, realizing your thresholds, knowing when to spray. You don't use the big hammer anymore for all your solutions. You use a tiny chisel and a specialized herbicide or pesticide, insecticide to treat these problems that come up. And lastly, which I'm really going to drill into today, crop sustainability. How do we continue to farm well into the future? And that's how I define sustainability. I'm not going to really go into depth on that definition, but basically, how can we do what we're doing now many years in the future? And really, I'm going to divide this up into soil health, water conservation, and salt management, all of which are critical to understand and do well in our harsh desert environment. Again, I'm going to talk about, here's our lettuce cropping system. This is a typical lettuce field in Yuma. How soil health, water conservation, and salt mitigation is all important to producing this nutritious crop, which is needed by our nation. Again, we have challenges for our sustainability. As I discussed earlier, dams have stopped that natural recharge, and now it's our responsibility to recharge the land. Our soil pHs are really high, 7.5, 8.2. That ties up phosphorus, makes it non-available, but it also makes other nutrients more available. So we have to balance that interaction there so we don't over-apply.
No, that's all good.
We have high sodium in water as well. Our best water, the best water that we have is a 2.5 SAR. So even our best water is slightly salty. It comes from the river. Our worst water comes from wells, and a lot of areas away from the Colorado River have to rely on that and can get all the way up to 8.3 SAR or worse. We have minimal rainfall, less than 3 inches a year. Yes, less than 3 inches a year. And in fact, we hate it when it rains because that spreads disease and things like that. We'd much rather order it from our irrigation district and have it delivered to us through our canal systems. But we have to adjust our system because we don't have that natural rainfall to clear out the salt and other problems like that. We have a very fast carbon cycle, which makes carbon sequestration very difficult. The high heat spurs microbial growth. The wet conditions of the agricultural field and high tillage from these at least double crop systems really make it difficult to build carbon. We're lucky if you can get above 1%. The best farms here in Yuma might have 2%. And that's if you have a continuous addition of compost. But we have issues with that too, with the leafy green system, because if you are growing leafy greens, it is illegal to apply manure, and you can apply compost, but they're being cracked down upon it. And there's the federal law, and then there's the LGMA, Leafy Greens Marketing Agreement, which is a industry agreed upon standard, and they have their own standards for compost. And then the company that you might be growing with might not want the compost being applied. So that can be an issue. This is a sticker I made, by the way, for compost: lighter than air, stronger than whiskey, cheaper than dust. And by the way, that was the original slogan used to sell barbed wire back in the day. So good thing it's not on copyright anymore. So soil health, we've done some studies to create a baseline. What does that look like for us in the desert? We've got a lot of information coming from the Midwest on what that should look like for them, but what does it mean for us? So we got together with our soil health extension specialist, Dr. Dibankar Sanyal, and we did a soil survey of Yuma. Basically, we went up to farmers that we knew and said, give us a field that you think has bad soil health. Give us a field that's nearby that you think has good soil health. We want to test it, send it to laboratories, find out the difference between assays so we can figure out which lab analysis is best for us. Well, we concluded that the best, first of all, our microbial populations were super low. It's just a hard place for microbes in the Southwest. Right now, outside it's 115 degrees Fahrenheit, and all of our soils are bare because we're getting ready for vegetable season. So what do you think's happening to the life in the field? Good thing it rebounds quickly once it has a food added to it. We found out that the great tests for us were POC, which is permanganate oxidizable carbon. This is basically the active carbon, because we have a lot of carbon in our soil, but it's in the form of carbonates. You know, it may not be available. This tells us what is the available carbon. That was a very good indicator. PMN, which is potentially mineralizable nitrogen. This is basically ammonium or the easily decomposed nitrogen. That was a good indicator of soil health, as well as soil protein, which is basically how much life do you have in the soil that's slowly degrading and becoming plant available. If you want to capture that QR barcode, that'll take you right to that extension publication that we have written on that data. We also have issues with conservation tillage. We would love to do what they do in the Midwest and do no-till or reduced till, but how do we do that in a vegetable cropping area? This is what we call a spider. Plot spider was made by Keithley Williams. It's a 30 seed line planter in an 84-inch bed. Yeah, this is for planting spinach and leafy greens like spring mixes and things like that, where we're planting 3 million seeds per acre. Yeah. How do we do no-till when we're doing planting systems like that? And then when it gets wet, it gets all rutted up by the harvest crews that aren't even employed by the farmer. The harvest crews are employed by the shipping company that are contracted with the farmer. So the farmer grows a crop, calls the shipper, they come in and they bring in their own harvest crew, and then they just tear up the field. So how do we do conservation tillage when we have those conditions? It makes it very difficult. We've played around with some strip tillage equipment. This is an Orthman strip tiller. The idea is maybe if we make our raised beds and then we just kind of clean them up and let those roots degrade inside, maybe we can do something where we can get a good seed planting area, because all vegetable seed is planted very shallowly too. Lettuce seed, they say, is just dusted. It's planted at surface level. So how do we get that good soil to seed contact and still get conservation tillage? This may be a solution. We can at least go into maybe a transplant mode with that. Biochar, I've played around with it. First of all, it does not go through like a chicken manure spreader very well. It arches out. It's very lightweight, doesn't go out. I recommend mixing it with compost like you would like a lime or something like that, like a powder. That'll get it out on the field. We've played around with it. It deactivated the herbicide, right? So we had tons of weeds. It moved when it's irrigated. That measuring cup on the right, that's what happens when you add biochar to water. It separates out. You got a lot that's floating. So if you're doing flood irrigation, just washes it to the edge of the field. And we didn't find any increase in water holding. That red solo cup I'm holding up there, a hole is cut out the bottom of it, cone coffee filters inside, and we added material, weighed it dry, saturated it, measured it weight, let it drip dry for 2 days, weighed it again. It did not hold very much water. I think there's an illusion with biochar because it's so light and water is so heavy. Oftentimes you'll hear the claim of biochar will hold 10 times its weight in water. Well, biochars are not very heavy, and water is. So there's an illusion there. And so watch out for your application rates, especially when they're made on a weight basis rather than a volume basis, because it is very light. So just be careful when you're doing your application rates for biochar to calculate it on a volume basis versus a weight basis, because it does not weigh very much and you're going to be adding a lot. We're working on water conservation as well in our sustainability, so transferring over from soil health to water conservation. We're in a 24-year mega drought here in Arizona and the desert Southwest. The Colorado River is our main water supply. It is over allocated. The 1922 treaty with the 1944 addition put us on the hook for 16.5 million acre feet per year of water. The actual flow of the river now is 12 million acre feet. So we're over allocated. So every year we're pulling from our supply, our reservoirs, which is mostly Lake Powell and Lake Mead. Ag uses 75% of the water in Arizona. So any savings we can do in in farming with water is going to have huge impacts. This is a QR barcode that'll pull up a weekly report for the Colorado River Basin. The current contents of the river is 44%. So we're below halfway. 2 years ago, we were at a point where Hoover Dam was worried about not being able to supply electrical power to Las Vegas. We were that low. We've had a couple of decent years of snowpack, but we're still we're in tier 1 cuts right now. How much water do we use to grow crops? It's a big pressing question, and there's a data report that's come out with some data that's been generated since 2016. They've had ongoing studies where they put eddy covariance stations and satellite imagery in farmers' field to find out how much water is actually used. Current systems have found to be 80 to 90% efficient. Does that system down there of flood irrigation look inefficient to you? Well, it turns out it is very efficient. It is very efficient, 80 to 90% efficient. And we have sprinkler systems as well that are used to germinate our crops and also provide evaporative cooling. When they're planting in a week or two and it's 110 degrees outside, we need that to cool down our crops as they're germinating. Planted right now, a lettuce crop will be a 60-day crop. Planted in October, November, it'll be a 120-day crop, just because it cools down so much. This is how much water each crop uses, along with the water requirement to maintain salt balance. So we're looking at spinach. Spinach is really low. It's only 5 inches needed to grow it, and that's with all on sprinklers. So yay, eat your spinach, everybody. That's a very water efficient crop. Lettuce, you're using about 13.5. Broccoli, 17. Alfalfa, they're still compiling it, but it's way up there. But we get 9 to 12 cuts a year of alfalfa here. So yeah, we're using a lot of water, but we're also taking a lot of biomass off. Cotton uses a lot as well, which is most of our cotton farmers are older. And in Yuma, they're transferred away from that because it kind of messes up with the vegetable season, which is the most profitable season here. So there's less cotton being grown in Yuma, but there's a lot in the middle of the state. But most of those farmers, to be honest, are aging out, and it's harder to get new cotton growers in the game because it's such tight margins. Things we can do to help save water. We can look at our sprinkler calibration. This is a catch cup study that I conducted. You got to go barefoot and slop around in the mud for this one. Just catch cups and look at your patterns. Can you move your pipes around? Maybe you put the pipe on the top of the bed and have a dead bed. So we looked at that, but this was all good coverage. Drip irrigation. It's difficult to have drip irrigation in an area that has less than 3 inches of water because it drives salt in the soil, but you can do it in the sand. Sand doesn't really have those problems with salt. And so if you spoon feed your water out with nutrients, you can grow some pretty good crops using drip irrigation on the sand. You can monitor the water that you have. All the sprinkler irrigation that I showed you, there's no water measuring device on that. The only device that they have is how many RPMs you have and your pressure, but they don't show flow. So you don't know how much you're using. This is a 10-inch flow monitor that I had built, and we've just lent it out to farmers to use, so they get a good idea of how much they're using. So if future cutbacks happen, they know how much they need. This is a tensiometer. It comes from Dr. Michael Kahn in Salinas. He calls it a 10-minute tensiometer. It's a DIY build. If you want, you can make your own moisture meter. You fill it up with water, you put it in the soil, and it makes a vacuum, and it moves that vacuum gauge to let you know when your soil is dry. It's great in salty environments because capacitance moisture meters can be affected by salt. And so this will just tell you how much draw is the soil is, how much, the drier the soil, the higher the vacuum, basically. It's trying to pull water out of that tube, and you can measure that as a semi-permeable tip. And also, this is going to be a gift that I'm going to be giving away today. So whoever wins that gift, I'm going to be mailing one of these to them because I love it so much. We developed a new method of irrigation and patented it. We're calling it solid set flood irrigation. We're taking that solid set irrigation pipe that's for sprinklers, unscrewing the valve and screwing in these bubbler heads, high flow bubbler heads that we 3D printed. We started getting into 3D printing. So if you're watching this and you're in Yuma, you want to do some 3D printing, come on down to the office. We'll print you up whatever part you need for your tractor or whatever. We'll do that for you. And we're evaluating it with growers now. So far, so good. It's a good method to replace basin flood irrigation, which right now is not very efficient because you just raise a gate and let a big pool of water go across your field. And it super saturates the area near the gate, and there's hardly any water at the other side of the field. So we're hoping this can give more precision, putting it out on a 30-foot grid rather than just letting it go across the field. We make educational videos too. We've got a lot of stuff on YouTube. You can click our link down there. It'll take you to our YouTube page. We have like 80 videos on there, but hardly anybody watches them. We've got like 20 views. Surprisingly, nobody likes to eat their vegetables. They just like to push it around the plate, I guess. We also do online on-demand training. If you need CEUs for pesticides and stuff, we'll take any video and turn it into a class with a quiz and all that stuff. We're trying our hand at something new. We're doing educational movies. We're making one called These Drying Times. It's a post-apocalyptic educational adventure movie. Yes, like Mad Max. We know that to get eyeballs of the youth, you got to make something kind of crazy, right? So we're going to try a new movie where heroes use water conservation methods to grow crops and survive in the post-apocalyptic future of a future with no Colorado River. When the river's dry, how do you survive? And we're going to enter this into the film festival circuit. Just today, I learned how to license music, and I paid money to have a professional band be on our soundtrack. So we're learning new things here in Extension. We also are participating in water conservation irrigation efficiency grant. The state legislature gave funding, $45 million to Cooperative Extension so that we could entertain grants from farmers who want to conserve water. We will give any farmer who is on flood irrigation $1,500 per acre, $1 million per farm to move from something from flood to something more efficient. Typically, it's a pressurized system, drip, micro sprinklers for citrus, sprinkler irrigation, linear moves, center pivots, that type of stuff. We are doing some work with gravity drip with the company Drip and looking at some new technology there as well. But basically, we look at it and look at the numbers, and if it looks good to us, then we will help get these improvements to the farm to save money. And not to save water, because we're there. We need this because I'm not going to go into how cheap water is, but water is still super cheap, like $30 for an acre foot. So we need this financial incentives to move, because it's not going to be in the future. It's not going to be that water's expensive. Water's going to be cheap. It's going to be that it's just not there. All right. Or it's going to be of such poor quality that you're going to have to do a lot to it to get it to be good.
About 5 minutes there, Robert. You're doing good.
Okay, perfect. So we're looking at soil amendment studies, clay shearing, polyacrylamide, alginate. Lastly, I'm going to talk about salt management. Salt's a big deal in the desert. So if you see here, that's not snow, that's salt. When you don't irrigate here and you just let the shallow water come up, it'll form this salt on the field. So it's very bad for soil structure and all that. We know that we need 15 to 20% more water than you need to grow a crop just to manage the salt. We normally do that in our pre-irrigation where we flat water a field, like what's in this picture here. It's typically done off season, so you don't lose your fertilizers. You can also irrigate every other crop and push the concentrated salt layer across the bed, so it's not in the center of the bed affecting the roots of the plants. You can also use soil amendments like acid, calcium. But acid's very dangerous. I've burnt the license plate off my truck using it. It's extremely dangerous. Calcium's important, but in a lot of our soils have high calcium already that just needs to be freed with the acid. Gypsum, you can add that too, but if your soils already have high calcium, you really only need the sulfate. You don't need the calcium. The idea is to push the sodium down and out of the field through drainage. I do a lot of experimental trials, doing drip trials. I'm looking for collaborators that want to do trials like this. I'll take a field, dig up the drip tape, cut it every 30 feet and pipe it in. So we got randomized complete block design. I'm pushing this Desert AgWise app too. It's a free app to help people manage salt, to know how much water they need to use in their pre-irrigations. The more data that gets put into it, the better our estimations will be to solving it. So in conclusion, regenerative ag and sustainable systems are needed to keep us farming into the desert for a long time to come. And by understanding existing systems and testing new methods, we will continue our production for years to come. Thank you. This is me. This is a newsletter that I kick out. So if you want to grab that newsletter real quick, you can just grab that with your phone or just email me directly at masson@arizona.edu. Remember, I got 2 S's in that last name. Okay, thank you everybody for your time and hope you have a great rest of your day.
Robert, thank you. That was awesome. Okay, so on the gift page, it looks like we're gonna have to do a drawing, I guess. Is that what we're gonna do? For who for your tool, the tensionometer?
Yep, I have a tensiometer. I didn't know how you were gonna do your gift deal, so.
Okay. Well, hey, let's do it real quick. While you're on here, who would this be applicable to? Like, this would probably be people that are flood irrigating or any type of irrigation, right?
Any type of irrigation, you bury it in the soil. You fill it up with degassed water. You basically boil water and put it in. And then as it dries out, the gauge goes up and you can tell down deep how much water you need.
Okay.
At homeowner, farmer, rancher.
All right. Is that something you'd be interested in, Larry? We're getting a head nodding. Where are you at, Larry?
I'm in Colorado.
Okay. And you under irrigation?
Yes.
Okay. All right. Let's do that. So we'll send, if you want to share your contact information with Robert,
I could do
let's
that.
do that and we'll get it sent to you. And yeah, appreciate you being on. I know Larry's been very attentive here too. So very cool. Yeah, thank you, Robert, for that. That's it's a little bit outside the normal context of what we do on these summits, but man, driving through the Central Valley of California a couple of weeks ago, just the production agriculture is crazy. How much is produced in just those small valleys there, and I guess in your country too. So that was really helpful. Yeah, send him some thanks and gratitude in the chat, and appreciate you joining us here today.